Hello everyone, welcome to the Chamari Devi Institute of Pharmacy Indore. In today's lecture, we are going to study some basic concepts of organic chemistry. Like we will study the effects which are very important in organic chemistry, like inductive effect and electromeric effects. So the flow of our presentation would be in the form of, first we will discuss definition, then types of inductive effects and its applicability, and some of the facts on the basis of inductive effect, and the electromeric effect. After that we will discuss about the types of electromeric effect and difference between inductive and electromeric effect. See, first one is the inductive effect. But first we will discuss the definition. It is said to be the permanent displacement of shared electron pair in carbon chain towards more electronegative atom or a group and is known as inductive effect. In other words, if you say with the help of the example, like here we have taken an example of CH3CH2Cl, that is chloroethane. If you talk about the atom attached here is the chlorine moiety and the carbon chains. So when we say that when there is an electron releasing or electron withdrawing species attached to a chain of atoms, especially the carbon chain, the corresponding and negative positive charge displayed instantaneously on the carbon atoms attached in the chain because of the electronegativity differences, and thus causing a permanent dipole moment in the molecule, and such an effect is known as the inductive effect. It is said to be the permanent kind of effect, and this is due to the displacement of electron cloud from one side of the molecule to the other side of the molecule. And basically in the example you can see chlorine is the more electron negative element than the carbon, and that's why chlorine pulls the electron pair to itself, and thus it attains a partial negative charge, while carbon, which is attached to the chlorine atom, having the partial positive charge, and so on. This effect is known as inductive effect. Then we will discuss what does it mean exactly and how this happens. Now I just want to inform you the formation of a bond. First we will discuss about the formation of the bond, specifically covalent bond. When there is covalent bond formation, there is mutual sharing of two electrons. One electrons come from one atom and the other electron come from the other atom. If in that forming or in that sharing, if the two electrons coming from two similar kind of atoms, then the bonded electron pair is attached equally by both the nucleus. Means that the bonded electron pair occupies a central position between the two nuclei, and this is known as non-polar covalent bond. But if you take two dissimilar atoms, one electron coming from one of the atom which is different from the second atom from where the electron pair is reaching, and then they are mutually sharing their pairs, then in that the electron pair is more attracted towards the more electronegative atom, and this type of bond results into the formation of poles within the molecule, and such molecule bonding is known as polar covalent bond. And this is the main reason polar covalent bond formation, that is the unequal distribution of the electron pair in between the two atoms because of the electronegativity difference, results into the effect which is known as inductive effect. Now you can see here two atoms are here, CH3X and CH3Y. When X is more electronegative than carbon, definitely X pulls out its electron cloud towards itself, and it is because of the electronegativity of the X, and hence the X attains a partial negative charge while carbon attains partial positive charge. While if you talk about in the second molecule, what we have is the CH3Y. If Y is less electronegative than carbon atom, then the bonded electron pair is more attracted by the carbon. Hence, carbon attains here a partial negative charge and the atom attached Y is attains a partial positive charge. Then this effect is known as the inductive effect. It can be plus inductive effect or it can be minus inductive effect, and it is always transmitted along a chain of the carbon. Here you can see in the picture, if you talk about the molecule CH3, CH2, 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 Cl, which is known as chlorobutane. In that molecule, the chlorine is attached here. It is having the electronegativity higher than the carbon atom which is attached to that chlorine, nearby carbon atom. And if you talk about the chlorine, because the electronegativity difference, it pulls out the electrons from the neighboring carbon atoms towards itself because of the nature of the chlorine moiety, electron negative element, and such results into shifting of the electron cloud from the carbon towards the chlorine, and in doing so the carbon attains a partial positive charge and chlorine attains a partial negative charge. And after, as you move from one carbon to other, the effect would be going on decreasing, and if you take go after the C3 carbon atom, you will say that the effect would be negligible, and this effect is known as inductive effect. It is represented by the symbol, that is the arrow pointing towards the more electronegative element or the group, and the decrease in the effect is denoted by using a greater number of the signs of delta, like delta plus, hash, 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 and so on. Next, types of inductive effect. Here there are two types of inductive effect, that is the plus I effect and minus I effect. If you talk about the plus I effect, it is known as positive inductive effect, and minus I effect, it is the negative inductive effect. Further, we will discuss it one by one. The negative inductive effect or minus I effect. It is negative inductive effect is also known as the electron withdrawing effect. Whenever there is electronegative atom or a group which is attached to the terminal of the carbon chain in a compound, the electrons get displaced in the direction of the atom attached. And if you talk about the groups which can have this effect, are said to be the nitro group, cyano group, carboxylic acids, your halogen groups, OH, C6H5 and H. If you compare these things, then definitely if you have OH molecules also and NO2 molecule, then the electron pull would be more towards the NO2 molecule because of the electron withdrawing effect of the NO2. And whenever these groups are attached with the carbon atom, then definitely these groups pulls the electron cloud towards themselves, and the respective carbon would attain partial positive charge and these groups would attain a partial negative charge. Such effect is known as negative inductive effect or minus I effect. While talking about the positive inductive effect or plus I effect, if the group is electropositive atom is attached to the terminal of the carbon chain in a compound, the electrons are displayed away from the atom attached. So in that case, if for example if a methane molecule is there and ethane molecule is there, definitely ethane would have more positive inductive effect compared to your methane molecule, and such results into plus I effect. Now, on the basis of inductive effect, we can explain here the acidity and basicity of the compounds. If you talk about any electron withdrawing group, for example, in the picture you can see here the CO group is there and CO minus is there, and whenever there is electron withdrawing group, definitely that CO is carbon atom is having some pull towards the electron withdrawing group, and because of this there would be chances of that the COH here would be in the form of CO minus because of the electron withdrawing effect of the groups attached to the carboxyl group. Now, if you talk about just the reverse and electron donating group, if electron donating group are attached with the carboxyl carbon, definitely the carboxyl carbon would have some effect of the electron cloud from the electron donating group which are attached to the nearby to the carbon atom, and this is results into decrease in the acidity of that carboxylic group, while when there is electron withdrawing group there is increase in the acidity. Then it means that the acidity and basicity can be decided on the basis of the plus or minus effect of the compounds or electron withdrawing group or electron donating group nature of the molecules. Now, if I talk about the group having plus I effect, then if these groups are attached to a molecule, they increases the overall electron density on the molecule, and the molecule is able to donate electron. And whenever there is donation of electron, then it is known as the base. So the molecule converts into a basic moiety. Similarly, when groups having minus I effect attached to a molecule, it decreases the overall electron density of the molecule, making it electron deficient, which results into the acidity. Thus, we can say in short, plus I group decreases acidity or increases basicity, while minus I groups increases acidity or decreases basicity of the compounds. Coming to the next, applications of inductive effect and some of the facts on the basis of inductive effect. Now we talk about the strength of the carboxylic acids on the basis of inductive effect. See, if we talk about an acid, definitely an acid is the strong acid. The strength of the acid depends on the ease with which an acid ionizes to give a proton. If it readily gives the proton, the acid is a strong acid. If it do not, then the acid strength would be decreased, that is, it results into the weak acidity of the molecule. Now, if we talk about the acidity of the carboxylic groups, it is maybe due to the inductive effect we have already discussed in the previous slides also, and thus strong electronegative groups helps in repelling proton from the OH of the acid or the COH group and making it the more acidic in nature. While talking about the di or tri substituted halogen acids, if we talk about an acid and if we talk about a halogen acid, then definitely halogen acid is a electron withdrawing group, then it becomes more stronger. If we talk about the groups like if we talk we have the comparison between trichloroacetic acid, dichloroacetic acid and chloroacetic acid. COH group is there, then COH group must convert into CO minus to become to show its acidity. If we talk about trichloroacetic acid, there are 3 chlorine molecules attached to the carbon from where the COH group is attached, and that carbon atom is having 3 chlorine molecule. It means there are electron withdrawing groups pulling the electron cloud from the center carbon atom towards itself, and they are not allowing the carbon atom to give its or share its electron pair with the COH group, thus making the COH group more readily available for proton release, that is H plus would be in the solution, and if it is in the high amount, definitely it will try for the trichloro substituted acetic acid. It is high because of 3 electron withdrawing groups, chlorine moieties are there, and if you compare the dichloroacetic acid, the acidity would be less as compared to the trichloroacetic acid, and likewise the acidity of the chloroacetic acid would be much more less compared to the dichloroacetic acid. Now coming to the other, the inductive effect also decreases rapidly as the group responsible for the effect moves away from the source. The strength of the acid is proportionately decreased. For example, if we talk about chlorobutyric acid, And in that chlorobutyric acid, if we talk about alpha chlorobutyric acid, beta chlorobutyric acid, gamma chlorobutyric acid, in that things, in all the three molecules, you can see the carbon where the COH group is present, and from that carbon the first halogen compounds attached at the first position is known as the alpha butyric acid, at the second position is known as the beta chlorobutyric acid, and at the third position it is known as the gamma chlorobutyric acid. If you talk about the molecule, then the electron withdrawing nature of the chlorine is there, and these electron withdrawing groups, if attached to the far away from the COH group, definitely it will decreases the acidity. So in all these molecules, alpha chlorobutyric acid is much more acidic as compared to beta chlorobutyric acid, and likewise it is more acidic as compared to gamma chlorobutyric acid. While you are saying all the three and you talk about the M-butyric acid without having any group, that is only COH group is there, it's only a normal butyric acid, no electron withdrawing group is there, and in that case the acidity is very less as compared to all the three alpha, beta and gamma chlorobutyric acid. So we can determine the strength of the carboxylic acid, di and tri substituted, as well as how the group as we move from the source, how the changes in the acidic behavior of the carboxylic acids can be there. Then alkyl groups are electron repelling groups. So if we talk about formic acid which is having no alkyl groups, they are electron repelling groups, or we can say they are electron releasing groups. If we talk about the electron releasing group, then if it is attached with the carbon or carboxylic group, if we talk about the carboxylic group, that it must release H plus ion to become an acid. Then if it do so, the CH3 group is attached there, and that CH3 group is actually the electron releasing group, and it is pulling its cloud towards the COH group, thus making it more balancing the COH molecule. And when we compared it with the HCOH group, then definitely there is no electron balancing from the CH3. We have only H is in the formic acid. So if we talk about that balancing, if balancing is not there, if the electron cloud would be not shared by any alkyl group, this H molecule from the COOH group is difficult to be in bond with that, because the molecule COO moiety is C double bond O is specifically the electron withdrawing in nature. So if only H is there, then it can readily donate its H plus ion. But when we talk about increasing the alkyl substitutions, then as you increase the alkyl substitution, it will be difficult for the acid to release its H plus ion, because the electron withdrawing nature of the C double bond O group would be balanced by the alkyl groups. So for example, in all these groups, if there is formic acid, then definitely formic acid is much more acidic, stronger acid than the acetic acid. Similarly, propionic acid, dimethyl acetic acid and trimethylic acetic acid are weaker compared to the acetic acid, because it is having only one alkyl group, and these are having a number of alkyl groups attached with the with this COH moiety. Then so overall we can say that the strength of the carboxylic acids can be explained on the basis of the inductive group. Second is the reactivity of the alkyl halides. We will discuss here the alkyl halides are the more reactive than alkanes because of the presence of the CX bond, which is slightly polar in nature, and because this is also because of the inductive effect. If you talk about the CH3Cl, definitely Cl the more electronegative atom than the carbon, and thus it's pulled its electron towards itself, attains a partial negative charge, and the respective carbon attains a partial positive charge. When you talk about the tertiary butyl chloride, for example, here in the next example, it's more reactive than the methyl chloride, because methyl chloride is having only one alkyl group which is there, and because plus side effect of the 3-methyl group increases the minus side effect of the chlorine atom by the repelling electron towards tertiary carbon atom, and thus reactivity of tertiary butyl group or tertiary butyl chloride is much more as compared to the methyl chloride. Thus chloride atom in the tertiary butyl chloride can be easily replaced by another atom, and as it is undergoes the substitution kind of reaction. So reactivity of the alkyl halide can be explained on the basis of again inductive effects. Now electromeric effect. Now we have studied here the effect. Earlier we have studied the inductive effect, which is the case with the sigma bonds or single bonds. And if we talk about the double or triple bond, then there is an effect which is almost same as that of the inductive effect, is known as the electromeric effect. But electromeric effect is a temporary effect, and it involves the complete transfer of shared pair of electrons to one or the other atoms joined by the multiple bond, that is a double bond or a triple bond. It is a temporarily but complete displacement of electron pair, forming a pi bond between two different atoms towards the more electronegative atom at the requirement of a taking species, and it is denoted by E. There are two types of this effect, plus E and minus effect. It is also known as a molecular polarizability effect, and it is characterized by the substitution of one electron pair for another within the same atomic octet of electrons. It can be indicated by the curved arrows as shown in the diagram here. You can see whenever there is an H2 molecule reaching towards this molecule, then there is a shifting of the electron pair, and electron shift, complete electron pair shift is known as the electromeric effect, and there is development of the plus or the negative charge to the respective atoms where the electrons attains its position. Then there are two types of electromeric effect, that is the positive electromeric effect and the negative electromeric effect. The plus E effect is when there is an agent or reagent which is having some lack of electrons, like electrophilic moiety is there, then there is displacement of the complete pi bond towards that reagent, and the second one would be deficient in that, and it will be converted into the carbocation. And this effect is known as, this is due to the reagent or the attacking available here, or the attacking species available here, and it is the pi electron of the multiple bonds are transferred to that atom to which the attacking reagent is bonded. This effect is known as plus effect. When we are talking about minus effect, when the pi electron of the multiple bonds are transferred to the atom to which the attacking reagent does not get attached, is called the negative electromeric effect. While, for example, if you talk about the moiety here, cyanide molecules are there, cyano molecules are there with the negative charge. They are attacking towards the carbon which is attached with the C double bond OH, that is the aldehyde group. Here in that carbon, the oxygen will, as the attacking reagent approaches the carbon, definitely there is jumping of the electron cloud, or there is shifting of complete electron pairs towards the oxygen, and that's why the negative charge would be there on the oxygen. Such effect is known as minus E effect. And now after complete studying the inductive effect and electromeric effect, though both the effects are almost same, and there is difference in inductive and electromeric effect, what they are. If we talk about the inductive effect, it is a permanent effect, while if we talk about electromeric effect, it is a temporary effect. The inductive effect is the polarization of a single sigma covalent bond due to the electronegativity difference, while electromeric effect is the complete transfer of a shared pair of electrons to the one or the other atom joined by a multiple bond, that is double or triple bond. Then inductive effect do not require any kind of reagent, but electromeric effect, it needs the presence of an electrophilic reagent. Then induced charge here in the inductive effect appears as delta positive or delta negative, and in the electromeric effect we can say the inductive charges, induced charges are the integers like +1 and -1. Hope you all like this presentation, and hope it will build up your concepts of inductive effect and electromeric effect. Thank you so much.